Okay, so I'm going to give this a try. I feel like I've been having a few issues with Loom and my tablet both working. I'm not really sure if it's Loom or the tablet or what, but I thought I might just record this Zoom meeting. And I think this should work. So what I'm going to do is work through the first of our exploration and practice assignments um, on domain and range and some graphs and tables and see if this will help you. Hopefully it will. So I'll try and move through fairly quickly so this isn't a super long video. And besides, I have class in 16 minutes, so let's see if I can do it. So suppose the function c of x is how that's read. So practice saying c of x equals x plus x squared over 20 gives a car's stopping distance in feet. So that's the y value, that's the c value, the c of x value, where x is its speed in miles per hour. So we're plugging in speed and we're getting out stopping distance. That's a really important thing with functions. What are you plugging in and what are you getting out? So as x increases, what do I expect will happen? Well, as x increases, I'm going faster. Speed in miles per hour is increasing. So I expect that c of x, the stopping distance, will also increase. As speed increases, I expect that stopping distance will also increase. And that makes sense, right? So I think c of x will also increase. Okay, reasonable domain for this function, explain. Okay, well, domain is the possible inputs, possible x values, right? So, x values is the speed. Okay, so probably that would mean I'm gonna say maybe from like 0 would be my slowest speed. I'm not gonna have a negative speed. And then this is a car, so maybe let's say 80. Probably shouldn't be driving too much faster than 80. So we'll say 0 to 80, or in set builder notation, we could say x such that 0 is less than or equal to x, which is less than or equal to 80, right? And remember that the brackets here mean that we are including those values. We want to be able to go 0 miles per hour, and we want to be able to go 80 miles per hour. Okay, that seems good. So I'm going to clear these out and scroll down. Find c of 0, c of 15, and c of 40. Okay, so let's try drawing now and see if I can use my tablet here. So c of 0 would be, let's see here, I need to scroll up to make sure that I know what my function is, x plus x squared over 20. So c of 0 would be simply 0 plus 0 squared over 20, which is 0. C of 15 would be 15 plus 15 squared over 20, which is, let's see here, 15 plus, let's see what 15 squared is. So 15 times 15 is 225, divided by 20 is 11.25. And this equals 26.25. And it's important to put units. So I'm plugging in miles per hour and out is coming feet. So this is 0 feet. And this is 26.25 feet. So this is telling me that if I'm traveling 15 miles per hour, I will need 26.25 feet to stop. Okay. Oh, and that actually is what D is telling me. Use a complete sentence to interpret the meaning of C of 15. If I am driving at 15 miles per hour in my car, I will need 26.25 feet to stop. Great. Why does it make sense that at C of 0 equals 0? Well, it makes sense that C of 0 equals 0 because if I'm not moving, then my stopping distance should also be 0, right? C of 0, so I'm inputting a speed of 0 miles per hour. And then I am also going to have a stopping distance of 0. It doesn't take me any distance to stop if I'm not moving, right? And the name of this point on the graph is the y-intercept, right? When you plug in 0, you get out the y-intercept. So that's the name of the point on the graph. Okay, parentheses are super helpful here when you're plugging values into your function. Okay, I'm going to clear all this. And I'm going to scroll down. Use the table at right to find C of 60. Okay, C of 60, I'm plugging 60 into the function. So 60, the input is right here. And so I am looking for this point right here. And it looks like C of 60 is 240. So I'm going to say that it is 240 feet. Okay, how is C of 60 read? Well, it is read as C of 60. That is how I read C of 60. Great. Okay, clear all drawings, scroll down. We've done the first page. What is the independent variable for the graph at right and what does it represent? So independent is what I'm plugging in and that's on the x-axis. So it looks like it is x and it represents speed in miles per hour. What are you able to see on the graph that you were not able to see in the table? Well, I'm able to see that this is continuous, that there are speeds in between 0 and 70. I'm able to see that it's a bit curved. I can see the curve there. And I'm able to easily see that as x increases, so does C of x. Although I could probably see that pretty easily in the table as well. Okay, so I'm going to clear that and I'm going to scroll down. Use the graph of S of x to approximate S of 45. And what is S of x? Well, S of x equals x plus x squared over 12 models the stopping distance of an SUV. Okay, traveling at speed x miles per hour. The graph below shows both S of x and C of x. So use the graph of S of x to approximate S of 45. So 45 is my input. So I am going to come over here to 45 and go up to S of x and find a point approximately on there. And it looks like that my y value is maybe about, I don't know, let's say 220. So I'm going to say here that S of 45 is approximately equal to 220 feet, meaning it will take my SUV 220 feet to stop if I'm traveling at 45 miles per hour. Now find S of 45 exactly using its formula. Well, that would be S of 45 is equal to 45 plus 45 squared divided by 12. And if I use my handy dandy iPhone calculator here, 45 times 45 is 2025 divided by 12 is 168.75 plus 45 is 213.75. And that is the feet. So you can see that these are not quite equal. So I really need an approximately equals to here because this was a guess from the graph, whereas this is the exact value that I found using the formula. Okay, when comparing the graphs of C of x and S of x, why does it make sense that C of 60 is less than S of 60 based on what they represent? So basically what we're asking is, why would the stopping distance of a car traveling 60 miles per hour be less than the stopping distance of an SUV traveling 60 miles per hour? And so the answer to that question is, well, SUVs are bigger, heavier, so they need a longer stopping distance, right? It's harder to stop an SUV. So it makes sense that S of 60, which is right there, right? S of 60 is right here, would be bigger than C of 60. It takes longer for the SUV to stop. Okay, let's clear all these and let's scroll down. What is the range of C of X? Okay, the range is the possible Y values. So let's scroll up to see for C of X. Okay, so its bottom Y value here is 0, and its top value looks like it's about 300 and something. If I scroll back up to the table, I can see that it's actually 315. So it looks like the bottom value is 0 and the top value here is 315. So that range is given by this total range, right? That's the Y values. So it looks like from 0 to 315. Okay, so scrolling back down here, possible Y values is going to be in set builder Y such that 0 is less than or equal to Y, which is less than or equal to 315. So Y is between those values. But for the range of S of X, it looks like, scrolling up, it goes from 0 all the way up to, oh, I don't know here. It looks like, let's estimate 480. So that's an estimation, but that's what I'm going to put down here. Say, well, it is Y such that 0 is less than or equal to Y, which is less than or equal to 480. So you'll see that the stopping distances are larger for an SUV than they are for a car. Okay. When thinking about stopping distance, why might the range of C of X be important to know? Well, I mean, we want to know, right, what our following distance should be, because if we're too close to a car in front of us, then we're not going to have enough distance to stop. So if we're going really slow, maybe the distance doesn't need to be as much. But if we're going very fast, we want to have a longer following distance. Okay, so I think that's, I just have time to do 1 and 2 in this video. But for those of you that want to look for, number 3 and 4 and 5, I'll be making a video for that as well. So thanks for watching. Hopefully that was helpful. All righty. Bye.